Hello, everyone, and thanks for joining me today. So today we're going to talk a bit about Vyper, and with a focus, of course, on the state of this curve smart contracts. So what we're doing, what we expect the language to build, what is coming next, and yeah, maybe to tell you a bit more about myself. My name is Alberto, as Parvina said, and I'm a smart contract developer at Curve. So my main focus is working daily with Vyper and smart contract programming languages. And yeah, probably if you've lived under a rock in the past years, this is what Vyper looks like. So as you can see, it really looks very close to Python. The syntax is very Pythonic, which is not a coincidence, and we'll get into why later. And as you can see, it tries to translate elements that come from the smart contract world, like external functions, into Vyper decorator, like the external decorator you can see here. And the cool thing about Vyper is it is all about security and user friendliness, which is why this print statement you see here actually works out of the box the way you see it, regardless of whatever framework you're using. So it works with Foundry, Hardot, or even like specific frameworks to Vyper. So this is just to give you a sneak peek on what Vyper looks like for the developers in the crowd. Other than that, maybe something that is interesting to see is why we use Vyper at Curve. The short answer is to really keep it simple. Maths are easier to read with Python syntax. Curve smart contracts are historically very math heavy. So we wanted to have something that was more readable to use. And that's why we decided to stick to Vyper, even though in the early days, the language capabilities were quite limited. And yeah, in the end, the reason is as simple as Curve OGs were basically Python fanboys, and they wanted to stick to that kind of knowledge they had acquired over the years. Vyper has provided good tier support to Curve. Basically, whatever need we had, the language has evolved towards meeting that need that Curve had, to a point where like it almost got over specialized into satisfying Curve needs. But in general, like the Vyper team is incredibly responsive and is basically able to support all of its users nowadays. Back in the days, we even had some of the employees at Curve that would work on the compiler. But now there's a full compiler engineer team working on Vyper full time. Also, something that I really like about Vyper, and we'll see why a bit later, is that you don't need to be an EVM wizard to write good and optimized smart contracts. Vyper priorities are readability, efficiency, without having to go low level. So there's no need to use assembly. And in fact, Vyper disallows assembly completely. So some of the exciting updates that we have from Vyper 0.4.2 that got released just last week is that we have a feature that has been long requested, that is non-reentrant by default. What this means is, reentrancy attacks is a very common pattern that we have in smart contract development. Probably the most known attack was the DAO one that led to the fork of Ethereum in 2017. That was a reentrancy attack. And the idea is Vyper now allows through the language, just by adding one line of code, to make every single function in the smart contract non-reentrant. This also includes public getters, which protects us from non-reentrant, from read-only reentrances, which actually have affected Curve historically. So yes, this is one step forward that greatly increases Vyper security by default, because we don't have to think about reentrancy or non-reentrancy. We actually only want to specify functions that we want to be reentrant by default. And actually, there are very few functions that you want to be reentrant by default, like, for example, flash loan functions, which is not clearly the main, like the average use case for a smart contract. Something also that I'm excited about is that Vyper now exposes two low-level opcodes through in Python syntax that are create and create2 with the row create built-in function. And this is actually cool because this shows how Vyper is slowly becoming more mature as a language, and as it becomes more mature, more people want to adopt it. And as more people want to adopt Vyper, this also means that the language becomes more flexible, and it doesn't need to tailor only for Curve anymore, but it can satisfy everybody's needs. Just for context here, create and create2 have been added so late to the language, because even before that, we had some very interesting solutions to create factory contracts to deploy other contracts on chain. So if you're curious about that, you can take a look at blueprints, for example, which is something that Vyper pioneered, and it's actually really cool and used extensively at Curve. Something that also makes us very confident to use Vyper in production is the insane amount of security initiatives the Vyper team takes care of. One of them is Snake Pit, which didn't get a lot of attention, and that's why I want to talk about this here. So imagine if you could have a collection of all the Vyper contracts, smart contracts that exists ever, like every single smart contract that's been written in a public repository or deployed and verified in a block explorer. Imagine if you could just have a huge collection of these smart contracts that would allow you to do something very powerful. That is to basically efficiently research for vulnerabilities. Whenever there is a problem in at the compiler level, the Vyper team can build a custom version of the compiler, which is just going to flag contracts that are impacted by that vulnerability, and they're effectively able to automatically report to the writer of that smart contract the vulnerability, effectively disclosing. This basically gives you an insane coverage over vulnerabilities, and it tells you exactly who is affected, and it helps you mitigate this before funds are at risk. So yeah, this is actually possible. This whole collection of smart contracts exists. It's called Snake Pit. It has been developed by the Vyper team in collaboration with Chain Security, and it actually covers more than 20 chains and 30,000 smart contracts overall, which is quite a big number. And you can imagine how easy it is to report vulnerabilities once you can mass check for them. So yeah, this gives us confidence to trust the compiler in production, because when there is an issue, it's really easy to identify it and know which contracts are affected and which are not. Something that I'm personally very excited about is Venom. So for those of you that are less familiar with compiler engineering, the idea is compilers usually can do gas optimizations automatically, algorithmically. And the way they do it is through an intermediate representation, IR, which is in the case of Vyper's IR is called Venom. And the idea is it takes inspiration from LLVM, which is like the golden standard when it comes to intermediate representation for compilers, and has been adapted to be simpler and work with stack-based virtual machines. Yeah, so you can read more about Venom, but why are we talking about Venom here? Well, actually because it's leading to very exciting results. So before we go into the benchmarks, we're going to compare two different implementations of the ERC20 token, one from Vyper and one from Solidity. And you can actually see that even if you this is the implementation from Solidity built by Vectorized. And if you look at it, it's like a piece of art. It's low-level assembly. It's optimized to a point where it's not even Solidity anymore. It's really mostly U, which is like this low-level language very close to assembly. And you can see that this function is not very readable, but it's extremely optimized. It's state of the art. And if you look at the gas consumption, it's very low. But what is even more interesting to see, for example, let's look at the approve function. If we look at the mean for the approve function, on the top, you see Solidity, that's roughly 16.8K. And down, you can see the same function for token written in Vyper can actually give slightly better results. Again, the difference here is very small, but the idea is this is state of the art. And the difference is that the Solidity function looks like this, and the Vyper function looks like this. It's just human readable code, basically Python code. And yeah, it's very readable, and it's just as efficient as handwritten assembly. So I think this is quite powerful. And the idea is now, the thing is, Vectorize had to spend many hours to handcraft this smart contract for the ERC20 token. Well, the Vyper compiler can basically automatically execute those algorithmic optimizations at the compiler level to every single smart contract you write. This is very powerful if you think about it, because it basically unlocks a senior assembly engineer that can optimize their contracts for free by just compiling into Vyper and enabling the Venom option, which is actually experimental right now. But this is why at Curve we're pushing really hard on the formal verification side of things. So both the HEVM team and the Certora team have been working on equivalence prover for Vyper, or more generally for smart contracts. And the idea is we are really pushing hard for adoption of this equivalence provers. The idea is simple. Imagine you have a not optimized Vyper smart contract and a Venom optimized Vyper smart contract. You can actually prove formally, like if it was a theorem, that those two contracts in every single scenario, they lead to the same behavior. This means that by performing algorithmic optimization, the compiler is not introducing any additional risk. This is particularly interesting for smart contracts where you really want to be sure that like you're not creating any new attack vectors. And yeah, so far the HEVM team has been collaborating very closely with the Vyper team. I think they use HEVMs for some formal verification tests at the component level. But we're also working with Certora, and this is a particularly excited about that. We're currently discussing a grant with Certora, and the idea is we will be able to verify most of our critical smart contracts at Curve, like the well-known stable swap, crypto swap, and who knows, maybe also Lamaland. And the idea is we will basically get all these optimizations for free. And when I say for free, I mean that it basically comes without a risk because we're formally verifying that there is no additional risk added by the compiler by performing those optimizations, which is actually something, yeah, that it's very powerful because, again, it applies to every single contract that the Vyper compiler can touch. Also, to conclude, something that I'm particularly excited about is some of the upcoming features for Vyper. And these two are particularly exciting for Curve. So I'm going to go first with raw return, which is coming probably sooner than you might expect. The Vyper team has currently been helping us, and they're going to do a special release just for us to get this to work. So what is raw return? It's really just a modifier that you can use to write proxies in Vyper. Again, remember, Vyper was built back in the days to satisfy Curve needs, and Curve deeply believes that immutability is a strong value that we want to endorse and protect. And this is why we never use immutable proxies, upgradable proxies. So the idea with raw return is that we finally allow Vyper to support proxies, upgradable proxies, diamond proxies, infinite proxies, whatever. And the idea is that it's actually also going to come useful for us, but for the broader public. And in particular for us, a sneak peek that I can tell you is that we're working on a new type of proxy that I think has not been done before, which we're calling a delegation proxy. And you'll probably hear about it later in the Curve announcements. So yeah, stay tuned for that. I'm particularly excited about it when it's going to be live. And also, something that I find particularly exciting is the runtime memory allocator. So just to give some context, for one of the Vyper design choices was to have static memory allocation, which means the memory allocation is on a compile time. This can be less efficient, but it doesn't really prevent you from doing anything that you would do with a runtime allocator in Solidity. But the idea is now Vyper also want to support runtime memory allocators because we found out that they're critical to build some important applications on chain, like multi-core smart contracts, which again are possible currently in Vyper, but they will not be as optimized because you always have to allocate the upper bound of the memory to make it work. So that's pretty much it. I don't know if we have the ability to ask some questions, but this is basically to wrap up why we love to work with Vyper. The team is amazing. They're super responsive. They basically work very closely with us. They basically make all our wish come true, which is great because you don't have to play with the constraints of the compiler. We actually enable the compiler to improve alongside our projects. And yeah, it's just very exciting to be on the frontier. And yeah, happy to answer any questions if we actually can. Thank you for listening.